Hi everyone, my name is Vlad Kurmaz, and today I would like to share with you a couple of tips and tricks which can be extremely useful and help your life a little bit easier from software development perspective. Before we jump into our presentation today, just a couple of words about myself. More than 2 decades in software development. I had a chance to work in different domains using the different tech stacks. Main focus during last years is to help teams build a painless, smooth development ecosystem, so we can focus more on solving real-world issues and not struggling with SDLC itself. Where I see myself in a couple of years, definitely blockchain domain and especially smart contract. We have a pretty simple agenda. I have just a couple of slides with high-level concepts, and then I want to jump into demo and show you how to put all these pieces together. And before we start, let me initiate deployment procedure. This is something we will need during our demo. Okay, let's back to the presentation. From my perspective, this is brilliant description for what we want from our continuous integration, testing, delivery, and deployment and operation. And but unfortunately, in the real world, it will be sometimes even impossible, expensive, or very difficult to achieve such level of automation. But the main point here is that when you make any decision, even any small decision, it's better that this decision will be aligned with this motto. In this case, you can be confident that you are moving in the right direction. First point I want to discuss, this release model, why we really distinguishing release model from branching model, and also this 90 plus 1 plus 9 plus 1 rule, which help us to utilize our development workforce effectively. This diagram represents one release cycle. Horizontal line represents time, and vertical line shows which version we want to work on in any specific period of time or point of time. So let's start from the left part of the graph. Point 1. Let's say that we successfully delivered September version 2021.9.0, and as you can see, 99% of our developers can start working on the next release. In this case, this is October release, and point 2 describes the situation. But we are in production, and we will definitely receive escalation, and point 3 describes the situation. So in this case, we need to borrow or deploy a new environment, deploy the version production, confirm bug, provide fix, run regression test, and deploy new version. Yeah. In our case, it will be push 1 for September version. So in this case, our team should be able to work simultaneously on the 2 versions. Meanwhile, when we work on our October release, it's better to start releasing the drops. Drop just small releases. Usually we deliver it every 2-3 days, and it's enough time to fix bugs from previous drop and implement new features. So every 2-3 days our QA team can start over and validate provided drop. Point 4, critical point for our release. And this at this point you need to say, okay guys, this is feature set which we completed, and we definitely will spill over other uncompleted features, and you will need to explicitly split your team in 2 parts. As you can see, 90% of your developers can start working on November release, but 9% should be able to work in CAB mode. CAB mode stands for Change Advisory Board. The main goal here, step by step, make your version more stable. And as you can see, you will also release again the small versions, but we use a different name for this, release candidates, but idea is the same. You step by step add and more stability into your version. But don't forget, we are in production, and point 5 highlights the situation. So again, we have push 1 for September version, and what we need to do, we need to do the same exercise we did for point 3. Borrow, deploy new environment, deploy version in production, confirm bug, provide fix, and deploy this version in production. So in this particular point of time, your team should be able to work simultaneously on 3 versions. Okay, let's say we are moving into end of the release, and was successfully passed all quality certification steps. And in point 6, we are ready to deliver our October version, and we just close the loop. Point 6 is the same as point 1, and we can start over and deliver next version. So this particular diagram uses 1 month as a release cycle, but it fully depends on your project, even different stages of your project. This optimal release time can be different. Yeah, it will be 1 month, 2 months, 3 months, and then even more when your project will more and more mature, and you will have more and more end-to-end test, automated end-to-end test, good pass rate, good coverage. You can shrink this time and, for example, deliver version production every 2 weeks, for example. Explicitly or implicitly, our software product lives in this 4-dimensional space, configuration space, when we have version, environments, parameters, and values for these parameters. And this picture tries to put all these pieces together and shows the relations here. The main outcome here is that you should be able to deploy any version into any environment and using the combination, any combination of your parameters for your specific project. Maybe this is most philosophical slide, but this it has some deep connection with what we are doing on a daily basis. So in our world, nothing can appear from void. Yeah, you need to do something, and then you will get the results. That is why we move in this simplified 2-dimensional space, when we act and then we get results. So you could not just jump from point 1 from point 2 on this diagram. You need to do something, and this is the same for any domain. But from my perspective, the key characteristic of software development is that some activity which we mark this as a process, they are very dynamic and like a fluid. For example, you don't see that the gravity direction change very much. Yeah, but in software development world, it's the case. You can wake up, new framework, new deprecation, new fancy worlds, new providers. And that's why it's at additional internal complexity into software development. So we also not only developing and covering requests from business domain, yeah, and we also fighting with internal complexity. And this is pretty much which can describe why software development is really a complex process. So from this diagram, as I said, we're not moving from point 1 to point 2. No, we move from point A to point B. And every time if someone says to you, okay, let's don't use Terraform, just create infrastructure by clicking the user interface. It could be a case, but everybody should realize that this is agile-ish approach, and immediately you are creating technical debt. Later on, it will be very, very difficult to redo it, rebuild it, because you will be building something on top of the solution. On the flip side, if you are sell that you need to spend some time refactoring some code or inject new tool set in your software development process, you should understand that you are losing the time, and you are moving not directly to the result point. Accelerators. So this is something which we use internally here in customer times. In other words, this is MVP, minimal valuable products, but the key difference is that they should be enterprise grade. Yeah, you want to use it and just pick up as a product, inject into new project, and use without any additional configuration. It's not something that you can use as a pitch and then throw it out when you get foundings. Another key part, we want to have our accelerators, our best practices in source at source code level. Yeah, it's always good to have some kind of presentations or Confluence page, but it's better to put all these ideas into source code. So as I said, we can very simply use it. And what you can see here is some simple diagram how we connect all our accelerators and real project repository. So at the left side, you see a simplified version of it, and at the right side, I put here 4 accelerators. First of all, accelerators for documentation. We use this approach also to manage architecture documentation for our project. For any new project, we just inject it and use this skeleton to store functional requirements, diagrams, and so on and so forth. There are also 2 additional accelerators for Node.js application for backend and React application, but the main actor here is this is accelerator clouds. This is what we will focus on during our demo. Yeah, I will show it how we do it during the demo, but the main idea, once we start our new project, we inject all these accelerators using the Git subtree. It's a very powerful tool. And as I said, yeah, the main actor here is now our cloud agnostic application. So why do we need it? First of all, as a service company, we are receiving a lot of requests from different domains, and also our customers want to use different combinations of technologies. Yeah, this is why we have to be truly cloud agnostic and provide uniform, smooth experience using the 3 major cloud provider. And as I said, also combination of different React, Angular, .NET, Go, and so on and so forth. This cloud agnostic accelerator helps us, as I showed previously, very quickly bootstrap a project. So from the day 1, we can start setting up our environments, even if we have only 1 landing page and some test backend endpoint. Usually for infrastructure as a code and using the Terraform, you can see approach when you have modules folder and also set of folders which represents different environments, and then you just inject or link source code from modules folder into your environment folders. We're using a little bit different approach, OSI-like structure, when we have a set of different layers. And the main idea here, we don't want to have any possibility, yeah, to make our environments different from each other, because it's a lot of the source from the source of the pain. So this is simplified version. As I said, we have a layered structure, and also internally they act like a nested doll. As part of our cloud agnostic accelerator, yeah, we provide a lot of code inside managed at network layers, because this is which can be very it can be very simply reused for different type of projects. For app layer, we just provide some small pieces of code which can be reused, and also if you build multi-tenant application, this is definitely absolutely application specific, and we do not provide any scripts here, because this is, as I said, fully application specific. So we already jump into demo. What I want to show you today is how we can use monorepo approach for microservices based project. Also how cloud agnostic accelerator can help us, and also how we can uniformly manage CI/CD requirement for this particular case for Jenkins and Azure DevOps, but it can be very simply extended to GitLab or GitHub Actions. Okay, let's say we are part of PepsiCo company and we want to start our new project. So let's create. Okay, we need to create an empty repository and configure user. User email. Okay, we are good. So let's start from the some key configuration here. First of all, you will definitely need gitignore file and also .env template file. This file will represent a set of environment variables every developer and CI system should define, and it's absolutely dev environment specific, maybe with some default parameters. The next part, version file. This is very simple file, but why do we want to have it? It just store exact version for your current code base. Usually you may use a branch name for this, but what to do if you are in detached head or you create just a local branch? And that's why we always want to explicitly have this file. And plus, all our scripts can read information from this file and use it during Docker build, Docker push, and also configuring all aspects, for example, for Helm installation, for Helm scripts. Okay, and two files which are environment specific, .env file, of course. So every developer, he or she check out repository should provide some additional variables, and context file. This is also a very simple file, and it's describe to which environments you want to connect. Yeah, and this is fully based on naming convention you have on your project, but in our case it could be CI environment, dev 03, UAT 01, UAT 01, and so on and so forth. So also our scripts read all this information and then use it during execution. So it's guarantees that you are connecting to exact environment you want to be connected to. Okay, let's make our first commit. Okay, let's include. Okay, I will show you how to include 3 accelerators, one cloud agnostic and one for front-end and one for back-end. Okay. Okay, what we are doing here, we are just injecting external repository with Accelerator Cloud's source code as sub-tree into our project. So, okay. 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 Same this. I need another subtree. This will be, sorry for this. It will be for our front-end part. Okay. Let's commit. This will be front. And another part is for backend. Okay, what we have right now. At current moment we have one accelerator which will be used for our front-end based on React. We also have additional subtree which will be handle our infrastructure scripts based on Terraform, and also one of the services for API, just for demo purpose. Okay, so everything fine. We are ready. We put all pieces together. Okay, let me copy a couple of additional scripts here. Okay, the next step. Different accelerators will require different third-party components, and what I need to do, one approach, I just need to read documentation and install all the software. But just imagine that you are working on a set of projects and they will require, for example, different version of Java or different version of kubectl or Terraform. Yeah, some of the ecosystem has their own solution for this problem, like node version management. I know we can use alternatives and so on and so forth, but there is no some umbrella solution for this problem. So we are using the project Talon. This is the story for another day, but in a nutshell, Talon allow you to create fully isolated developed environment, and it also cross-platform and transparent, and allow you to do the same to create the same build process for dev environment and for CI. I will show also in a minute. So let's check these files and see. Okay, for our root project, what we want to have, we want to see AWS CLI, we want to connect to AWS, we need also kubectl, we want to connect to our Kubernetes cluster using the command line tool, and also we need Azure CLI. Let's check what we need for our infrastructure. Since we are using our accelerator is based on Terraform, yeah, we recently switched for version 1, so we need this software to be installed. Let's check front-end part. Okay, our front-end part requires Node 16, so guys, bump in this version and it should be installed locally. Okay, let's check what we have in services. As you can see, we need to use a different version for to build our component. But okay, Talon can handle it without any issues. Okay, let's open. So what we can do here, just run prerequisite scripts. So these scripts will go one by one and check all our components internally, and read this configuration file, and also deploy those components, and then run init for our Node.js application. So let's give it a try. Okay, to save us a little bit of time, I ran this before, so it will just confirm that necessary components was installed already. At current moment, yeah, it's initiate run npm init for our front end and for backend. Okay, we are good. Let's check it. So Talan will install all third-party components locally. Yeah, it will not affect or update any of your internal configuration. For example, if you have Java 8 installed, yeah, and your project required Java 11 or Java 16, yeah, it will be installed locally and connected to the project. Yeah, once environment cleanup is very simple. You just delete this root folder with your project, and your system is clear. So let's just check it. And based on this information, as you can see, we need specific version for AWS CLI. We have the same for Kubernetes. Specific version, this version will be connected. The same for Azure CLI, but for Node.js. If you recall, two different accelerators requires different version of Node.js, and yes, this will be installed and properly connected to the corresponding components. And of course, Terraform version 1.1. Yeah. Okay, the next one. Let me open. Good. What I want to show you here, how to run these accelerators locally. Talent server content. Just run React application in debug mode, in developer mode. Let me open and show you. Okay, yeah, this is minimal viable template accelerator. It's contains some basic functionality you want to have in your application. Yeah. It fully depends on what you want to have as part of your accelerators. And let me do the same for services. Services side, yeah. This is backend. Microservice from the backend. Let's check working point. Yeah, as you can see, it works. Get return information about our API version 1. Okay, so as I said, we can immediately start developing our software. And another feature I want to show you that using this Talan, we also, okay, first of all our accelerators are Dockerized, so you can very simply build Docker containers. So let me show you how you can do it. I will not build Docker images, but just run it in the dry run mode. Yeah, first of all, this build command will utilize all environment variable we already provided, yeah, front end, and also will read specific version from the version file, yeah, use registry we provided, and also push it. So once you connect all these pieces together, you just need only one actor, container registry, and you're ready to build, push, and then deploy your ecosystem. And plus I want to show you how Talan helps us to create some uniform CI/CD. I will use, for example, Jenkins and Azure DevOps pipeline. As you can see, locally I use pretty much only Talon command, and we can reuse it at the CI side also. So in most cases, yeah, we do not change very much our Jenkins files, because all complexity, they are part of Talon scripts. So if, for example, you are switching your and need to bump Java version from 8 to 11, yeah, you can do it locally, update Talon scripts, test it, commit it, yeah, and CI system using the Jenkins and using the Talon will deploy specific corresponding correct version of Java, and will be used during the build process. You can see this one, all Talon commands. And this is pretty much the same for Azure DevOps. You can see different format, different ideas how to implement CI/CD, but from Talon perspective, the operation actions will be the same. So I prefer to think about CI like a silly developer who just can push button and build everything. But all other actions should be the same. So you should be able to do anything from a local machine and from CI system in the same way. Okay, so as I said, we are good to go, and at current moment we are ready to deploy our infrastructure. So let me show you. I will, if you recall, yeah, I initiate deployment right before starting our meeting started, and because it takes some time. But once you configure everything, you just can run this command, and in dry run mode, it will just go one by one and check all the layers and just initiate Terraform commands. Okay. Oh yeah, as you can see, this is for AWS and this is for Azure. Yeah, let's check what we have. Name. Okay, and as you can see, the name of our project is DevOps Stage, and our environment is dev01. Yeah, so changing these variables and content of the files, you can create any number of environments. And let's see what we have in Azure DevOps. Also, yeah, we're using the resource groups here, and what you can see that, yeah, we also deploy our network infrastructure, also Kubernetes cluster, also Bastion, here using the native Azure DevOps items for Azure DevOps. So yeah, this is pretty much it for a demo. And I just have a couple of slides. Okay, what is next? Talon is already in open source area, so you can find it in GitHub, NPM, so give it a try. And we also plan to release our cloud agnostic accelerator as part of open source community, and it will provide uniform experience from Azure, AWS, and Google Cloud. So that is it from my side, and thank you very much for your time. See you soon. Bye.